Hi data scientists, welcome to Breath of Data Science. I'm Tarun. I have a master's in data science and I'm currently working as a data scientist in Germany. I created this channel to share my knowledge of data science, programming and the related things. In my last video, I talked about measures of proximity in data mining and machine learning and how you can use them to perform transformation of data during analysis. And if you haven't checked out that video, you can find it in the description box or on the top right of your screen now. So now today, continuing on that, I will discuss, I can say potentially one of the most important topics in data science and machine learning, which is data pre-processing. This is part one of two-part video. In the first part, I'll cover what is aggregation, what are the different types of aggregations are available and what purpose does aggregation solve. Then what is sampling and what are different types of sampling that are available. And then what is dimensionality reduction, what is its purpose, and what are the techniques that are available to do dimensionality reduction. And then I'll start with feature subset selection, which will continue in the part 2 of the video. This is the most important topic and I can vouch it from my experience as well, because the data that you receive or you have in real life to solve the problems using data science is not the cleanest data or the best possible form of data. So you always have to apply some kind of data pre-processing in order to make it enough clean or make it legible enough so that it can be fed to machine learning algorithm. As I said, that the data pre-processing refers to the steps that you apply to make the data more suitable for data mining and the machine learning algorithms. And it usually falls in one of the two categories. So first is selecting data objects and attributes for your analysis, and the second is creating or changing the already existing attributes that can fit the particular type of modeling or any type of analysis that you have in your own mind. First is what is aggregation. In very simple terms, it is referring to combining two or more attributes or data objects into one single attribute or one single data object. And the purpose behind aggregation is that you want to reduce the amount of data that you have. If you want to do data reduction, then it reduces the number of objects and attributes present in the data, and this results into smaller data sets and hence requires less memory and processing time. And hence this step of data reduction within aggregation may permit the use of more expensive data mining algorithms that are more resource exhaustive. The second purpose is to change the scale of data. So aggregation can also act as change of scope or scale by providing a very high level view of the data instead of a low level view. So for example, cities can be aggregated into regions, states or countries, or days can be aggregated into weeks, months and years. The more the stable data and the less the variability, and aggregation helps you with that. So now let's talk about the second approach, which is sampling. Sampling is a very commonly used approach for selecting a subset of the data objects that we are going to analyze. And the key aspect of sampling is to use a sample that is representative of the entire data set. A sample is representative if it has approximately the same property which are of interest as compared to the original data set. If the mean or the average of the data object is the property of interest, then a sample is representative if it has a similar mean as compared to the original data set. So there are a few types of sampling also that you can potentially do. The first is simple random sampling. So there is an equal probability of selecting any particular item in this particular type of sampling. The second is sampling without replacement. So as you select one item, it is removed from the entire population of the dataset so that it's not picked up again. The third is sampling with replacement. In this type of sampling, objects are not removed from the entire population of the dataset when they are selected as the sample. In this sampling with replacement, the same object can be picked more than once. The next one or the fourth one is stratified sampling. So what this does is you split the data into several partitions and then draw random samples from each partition. The way it helps is you get a higher probability of getting the most representative data through this kind of sampling because you have divided the data into different portions and then you are sampling from each portion. The last type of sampling is progressive sampling. So in sampling, there is a general problem that you never know what a proper sample size would be, and it is difficult to determine as well. So adaptive or progressive sampling schemes are used in such cases. These approaches start with a small sample and then increase the sample size until a sample of sufficient information and representativeness has been obtained. Now moving on to third type of data pre-processing, which is dimensionality reduction. The term dimensionality reduction is often reserved for those techniques that reduce the dimensionality of a data set by creating new attributes that are combination of the old attributes. So what is the purpose of dimensionality reduction? First is to avoid the curse of dimensionality. To understand this, I mentioned it in a video earlier. I'll tag that in the description box below, or you can check it out on the top of the screen right now. The second purpose is to reduce the amount of time and memory required by the data mining algorithms. And third is to allow the data to be easily visualized. And fourth is that it may help to eliminate irrelevant features or reduce the noise within the data. So how can you do the dimensionality reduction? So there are a few techniques I'll mention too. The first is principal component analysis, and the second is singular value decomposition. And these techniques are too vast to cover in this particular video, so I'll create another video in the future where I explain these two techniques itself. Let's move on to the next type of data pre-processing technique, which is a feature subset selection. Feature subset selection is nothing but another way to reduce dimensionality of data, wherein you use only a subset of all the features that are available to you within the dataset. So for example, if the dataset consists of 50 features, then you might think, okay, do I really want to use the 50 features for my modeling or for my solving of the problem or the analysis? Or you might think, okay, maybe I can solve the problem with using 10 features or 15 features or only 5 features. So this particular type of method comes into feature subset selection, whereas you might think that, okay, in such a case you might lose information, but this is not the case if there is redundant and irrelevant features are present in the dataset itself. What are redundant features? Redundant features are nothing but duplicate, or all of the information that is contained within one data object is represented by multiple attributes. So for example, purchase price of a product and the amount of sales tax paid. They are not necessary to do the analysis because price of product is consisting already of the sales tax paid. Now there could be irrelevant features. So the irrelevant features contain no information that is useful for the data mining task or the data science task at hand. So for example, student ID is often relevant in the task of predicting students' grades. If you liked the video, then don't forget to subscribe, like and comment to support me in creating more videos like this. I will see you again next week.